Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ashraf bin Rozman. I am from section 46 Differential Equation SSCE 1793, and today we are from group 6. We would like to present our second order differential equation, second order application of DE, and I will start with introduction. An RLC circuit is an electric circuit which consisting of a resistor, an inductor, and a capacitor connected in series or in parallel. The three basic passive components of resistance, inductance, and capacitance have very different phase relationships to each other, but we can connect these passive elements together to form a series RLC circuit in series with an applied voltage supply. Okay, then here are some of examples of RLC series and parallel circuit. On your left is the series circuit, and on your right is parallel circuit, which contain only current, voltage, resistor, inductor, and capacitor in one circuit. After that, RLC circuit mainly used in our daily life, which have many applications such as an oscillator circuit. The radio receiver and television sets use them for tuning to select a narrow frequency range from ambient radio wave. Series RLC circuits are classed as second-order circuits rather than using first-order circuits because they contain two energy storage elements in one circuit, which an inductance and a capacitance, the symbol of L and C. So that's why the application of second-order differential equation, which is some of it used in to build the RLC circuits. So then I would like to pass the next input to my friend. Thank you.
Assalamualaikum warahmatullahi wabarakatuh to the doctor and friends. My name is Muhammad Akil Haris bin Muhammad Sabri. Today we're going to discuss together one example of question about the application of second order differential equation. The question is circuit problem RLC. Okay, let's see the question. This question is second order non-homogeneous linear ODEs arise in the study of electrical circuit after the application of Kirchhoff law. Suppose that IT is the current in the LRC series electrical circuit shown in figure 1, where L, R, and C represent the inductance, resistance, and capacitance of the circuit respectively. Using Kirchhoff law, the differential equation where V, I, and Q represent the voltage, current, charge of the circuit respectively. If the initial charge and current are Q0 equals 0 and I0 equals 0, find the charge and current Qt, It in the circuit for t greater than 0. Given the LRC circuit with L equals 0.0625H, R equal to 250 ohm, C equal to 1 over 160000F, and ET equal to 60 volt. First, we solving in terms of Qt. This question, L di over dt plus Ri plus Q over C equal to ET. And then we do homogeneous equation by substituting the value that given, that L, R, C, and ET. And then after we substitute all, we get di over dt plus 4000 I plus 256,000 equal to 960. Then we substitute I equal to dq over dt. Then we get d open bracket dq over dt close bracket over dt plus 4000 open bracket dq over dt close bracket plus 256,000 equal to 0. And then we differentiate for the second time. We get d square q over dt square plus 4000 dq over dt plus 256,000 equal to 960. I think that's all from me. My friend, we will continue our discussion. Thank you.
This is the example of second order of non-homogeneous linear ODE equation. It is arise in the study of electrical circuits after the application of Kirchhoff's law. Suppose that I in terms of T is the current in the LRC circuit as shown in the figure, where L, R, and C represent inductance, resistance, and capacitance of the circuit respectively. By using Kirchhoff's law, the differential equation where V, I, and Q represent the voltage, current, and charge of the circuit respectively. If the initial charge and current are Q naught equals to 0 and I naught equals to 0, find the charge and current Q in terms of T, I in terms of T, in the circuit for T more than and not equals to 0. Even the LRC circuit with L equals to 0.0625 Henry, R equals to 250 ohm, and C 1 per 160,000 Farad, and E in terms of T equals to 60 volt. We are going to solve this question in terms of Qt. The equation stated there is a homogeneous equation. By substituting L, R, C, and ET, we will get di over dt plus 4000I plus 2,560,000 Q equals to 160. And then we will continue with the substitution of I equals to dq over dt. And then we will get d squared q over dt squared plus 4000 dq over dt plus 2,560,000 Q equals to 960. We will continue with further substitution of m equals to dq over dt. We will get the answer m squared plus 4000 m plus 2,560,000 equals to 0. And to find the roots, we can use the formula of m equals to negative b plus minus square root of b squared minus 4ac over 2a. And then we will get m1 equals to negative 800 and m2 equals to negative 3200. So the roots are real and distinct. Thus, the QHT equals to AE negative 800T plus BE negative 3200T. Okay, now we are going to find the QP in terms of T by using the formula of XRC. When R equals to 0, the QP in terms of T equals to C. Since there are no similar term in QP in terms of T and QH in terms of T, thus the QP is equal to C, the QP prime equals to 0, and the QP double prime is equal to 0. Then we are going to substitute the QP prime, and the QP double prime into the characteristic equation to find the C. Thus, we're going to find the C equals to 0.000375. Hence, the QP in terms of T is equals to 0.000375. And then for the final answer of QT in terms, QT equals to QH in terms of T and plus with the QP in terms of T. QT equals to AE negative 800T plus BE negative 3200T plus 0.000375. So now from there we are going to find the unknowns of A and B. When T equals to 0, QT equals to 0. We are going to substitute these values to get the answer of A plus B plus 0.000375 equals to 0. This is the equation number 1. And then when T equals to 0, I equals to dq over dt. Substitute these values and we will get 800A equals to negative 3200B. This is the equation number 2. Substitute equation 2 into equation 1 and we will get negative 4B plus B plus 0.000375 equals to 0. And then we will calculate them and finally get B equals to 0.000125, and A equals to negative 0.0005. So the final answer is Qt equals to negative 0.0005 E negative 803 plus 0.000125 E negative 3200 T plus 0.000375. That's all from me. I'm Lukman. Thank you.
RLC circuit in electrical engineering is one of the application of second order differential equation. RLC circuit equation can be written as L, which is the inductance, times with dI over dt, which is change of current over change of time, plus with the product of resistance R with the current flow in the circuit I, plus with Q, capacitor charge, divided by C, capacitor capacitance, equal to E with the function of T, which is the voltage source.